here we have Andy Bennett. He's our Director of Sales Engineering for EMEA. And he's going to be talking about something really cool. And he's promised this is going to be the best presentation of the lot. Right, Andy?
Basically, the background behind that, and I don't know why that's not looking good. Okay.
The rest of it is good.
Yeah, the rest of it's gone. Okay, I can talk around that. So basically the background, we were approached in 2011 by, early 2011 by VMware. Basically they wanted to engineer a solution for their internal cloud and their virtual private cloud to compete with the solutions they had for vBlock and vPod from EMC. This one? Oh, okay, sorry. For vBlock and vPod, which for those of you who don't know is EMC's and NetApp's equivalent of a complete pod cloud architecture. What they wanted to do was they wanted to engineer a solution that was more cost effective for some of the customers that weren't quite in that price band. And the primary engineering goals for that were to be able to engineer a solution that gave a good cost per terabyte cloud type design that would provide scale out in the future to support a large number of VMs. But the primary goal on that cloud stack design was based on getting a cost per terabyte type solution. So we were helped to be involved to do that. So what I got together with the IE engineering team from VMware, for those of you that don't know that team, they're the special projects team. They deliver the hands-on lab. They deliver beta testing of VMware code that's maybe a year, 18 months out. They do large special projects for VMware. They're responsible for the cloud architecture within VMware on a proof of concept basis, and they're also responsible for delivering the hands-on lab that's delivered by VMware at their VMworld show every year. So what we did was we got together with the guys and we came up with a stack design using best of breed x86 technology that was commonly available, which was the design goal from the stack. So some of the partners we use that for data on, we use their JBOD, Seagate disks, STEC SSD, our software stack, Arista switching, Supermicro server hardware, and all of that was delivered by a service organization called MDSV in the States to provide a complete end-to-end cloud stack. The requirements, as I said, was to run a high-density generic cloud workload. Cost per terabyte was the primary design consideration, but good IOPS performance was very, very important. It is for a cloud type workload. Next center heads design needed to be scale out for future because they didn't know how big their cloud was. I mean, part of that is the problem that you have with cloud architecture is you don't know what you don't know. You don't know what customers are going to attempt to run on your cloud. And it needed to be a classic type pod scale out design. So that's what the stack looks like. Each cloud pod is a 2-rack. As you can see there, we have up to 120 compute servers. That's 1,440 compute cores. 11.25 terabytes of memory in the compute layer of the stack. We have Arista switching on the right-hand side, top of rack and core 10 gig infrastructure. And the stuff in yellow is ours. So it was basically 2 HA pods, 6 JBODs, 720 terabytes raw capacity to provide the infrastructure for all of that compute. In terms of number of VMs the platform was designed to run, it was targeted around the 8,000 VM size. Next one. Next center storage pod in a bit more detail. It's based on 2 heads, as I said, 2 2U Supermicro heads with 144 gig of RAM per head, 360 nearline, and I'll stress that again, nearline 7200 RPM SAS drives in our solution, because once again, cost per terabyte was the primary design consideration that we were asked to design to. So we were actually asked to design to a price point. Okay, we have some SSD. For those you don't know, Next Center storage pools leverage the hybrid storage pool design, and it's the SSD that allows us to get some of the performance that we get, and I'll talk more to the performance later on in the presentation. So what did the Next Center storage module look like when we laid it out in terms of the design considerations? It's an active-active cluster on each pair of head nodes. 2 pools in the design. Layout was optimized for a balance between capacity and performance. It was the best choice between the two. 30 logical RAID groups per pool and SSD accelerating that. That left us at 720 terabytes raw, 480 terabytes per pod usable, just short of a petabyte to support that level of compute. Basically, a bit later in the year, as we were doing the POC on the cloud, everything was going fantastic. VMware came to us. They came to us in beginning of June, just before the VMWorld show, and they said, we really like the cloud design you've done for us. How would you like to take it for a road test? I said, what do you mean take it for a road test? They said, so how would it be if we invited you to run the hands-on labs alongside some of the other vendors? Who in the room knows what the hands-on labs are from VMworld? Okay, so I've got a few people that don't. So let me explain to you what that is. VMworld hosts a show. The Vegas show gets about 22,000 visitors, of which about 2,000 of them are press. During the show, you can, from 8 in the morning to 8 in the evening, come and take a VMware learning experience, which is based on sitting a whole pile of their labs on a VDI-based session desktop. They do them in groups of 500. They're every hour on the hour, and they roll 500 people in and out this room. Okay, I'll talk more about the workload. So it's actually quite an intense workload. Now, if you're the size of organisation we are at Next Center, you have 2 choices when VMware come to you to say that. You can say, wow, we're not quite ready yet, come and ask us next year. And this platform, you've got to remember, was designed on cost per terabyte, not for the extreme workload, and I'll show you how extreme that workload is a bit later, that the hands-on labs bring. Or you can turn around and say, yes, we want to do it, and if you crash and burn at that workload and you don't fulfill, it's probably the most public place that you could choose to do that. So as an example for that, our cloud was already provisioned and stood up and working. The other 2 vendors that were involved in the hands-on lab get a special choice to deliver their particular flavour of hardware to just deliver the labs. Example of that, NetApp had 2 FAS3270 appliances with 144 15K disks. Okay, 4 PAM cards per appliance. I don't know if any of you know what the PAM card from NetApp is. It's an all-memory based read accelerator card. They're quite expensive. And that's the maximum configuration you can put in one of their heads. EMC chose to deliver 2 VNX platforms. One of them was all enterprise class SSD, so it's a complete flash appliance. And the other appliance was 140 plus 15K disks, backed by a fast cache tier of 4 terabytes and a fast VP SSD storage tier. We never got disclosed how many SSDs were in that, but we know there are a lot. Both solutions that you have on that screen, list price over $2 million US. So what does the hands-on lab workload look like? So let's talk about that in a bit more detail for you. Each lab provisions up to 26. So there's 26 labs involved. Completely random choice by the user. They can sit down and take any one of the 26 labs. In fact, some people just go to VMworld to take the labs. They sit there, they take all 26 labs, they get a special certificate for going through the whole VMware training course. So they try and cram as much training as they can into the few days that it shows on. Each lab provisions 4 to 25 VMs per lab. of which the largest VM was 26 gig in its own right. Okay? They are created and destroyed per login, and as I said, 500 people come down, they sit down, plonk down, they run the lab, so that's per user, so that's 500 an hour. And the lab choice is completely random, so it's not like I can go, everyone's going to take this lab, I'll pre-populate that into my caches. Now, because the labs are a build-on type training course, you develop your first VM, and depending on what path you take, you're delivering sub-module VMs within. So it's a VM layered inside a VM, layered inside a VM, layered inside a VM. So nested VMs, I don't know for any of you that have tried it, are highly latency sensitive. Okay, if you have latency in the first VM, by the time you're 10 VMs down, you're sitting there, you can go for a coffee, maybe have some lunch and come back and see what's going on. So this was not the type of workload designed for a platform that was designed not to deliver huge numbers of IOPS at low latency. For an example, a 7200 RPM hard disk has a latency of about 12 milliseconds. The 15K RPM hard disks that the other vendors were using has a latency of about 4 milliseconds, typically, in a typical design. And the latency of an SSD is sub 1 millisecond. So as you can see, we weren't overly enthralled about the choice of us having to run this high IOPS workload on our platform. So it was a bit of a risk for us, to say the least. The takeaways from that is, that means, based on the information I gave you, that's 148,103 VMs created during the Vegas show alone. And more importantly, they also have to be destroyed. Okay, that's one VM created and destroyed every 1.215 seconds throughout the course of the show. So as you can see, that's quite an extreme I/O workload. So the hands-on lab statistics, they don't just run the show in Las Vegas, they also run the show 3 months later in Copenhagen. And when we arrived at Copenhagen, they then, you don't mind when we finish at Copenhagen the 8 hours if we start firing up the labs at the show we're doing in Sydney, do you? So actually, during the time we were supporting VMware, during the Copenhagen show, we were also, during the night, running the show in Sydney. It was a much smaller show that we were running in Sydney, but it meant that we had 24-hour uptime on the platform during the time at Copenhagen, where at least at VMworld Las Vegas, it was an 8-hour window during the show. As you can see, people took over 18,912 labs were taken during that period. And the number of VMs we created and destroyed throughout all the labs was over 200,000. So just a bit of background here for you off slide. Originally, when VMware came to me and said, did we want to run the hands-on lab, they said, would you like to run 2 out of our 8 workloads? As you can see, when we arrived at Las Vegas, they said, actually, we've changed our mind, would you like to run 4 out of our 8 workloads? In terms of numbers that you guys might get, we served 10.3 billion NFS IOPS during that period. 3 billion NFS IOPS from one head in Vegas. Number of IOPS, 154,000 4K IOPS, sub 1 millisecond was a typical type of workload that we might see during that. When they do vMotions, i.e. when they're provisioning the larger files down at the end of a session, we saw a larger block size, and that's 40,600 16K NFS IOPS through a single controller. So what does that look like in terms of bandwidth? That's your IOPS count. If you go to the next slide, that's 1.3 gigabytes a second, 928 megas a second in read, and 370 odd megabytes a second in write. But we serve that workload at an average latency of less than 2 milliseconds throughout the entire period of the show. So the platform was behaving quite well at that point in time. So does everything go perfectly? Don't know if many of you know, we have a high availability plugin, and as you saw, we provision this as a highly available system. And things do go wrong. So we actually had a RAM failure at some point in the show. The partner head took over, cluster failed over, took us about 23 seconds to do the failover between one head and the other. And the partner head ran double duty for 6 hours. You might ask, why didn't we go and fix it? Why didn't we just go and fix it? Well, VMware have this policy, you see. It says that if a partner's hardware fails, no partner is allowed in the data center during the running of the show. That's just in case we go in there and pull EMC's cable out, right? So basically, the other head had to run double duty for 6 hours. Don't know whether you know, as an underlying byproduct of us using Solaris within Next Center Store, we get a really awesome fault management system, FMA, within Solaris. It's really intelligent. It was basically intelligent enough to tell us in Las Vegas the serial number of the DIMM that had failed in the head at the point we failed over. So we knew exactly where the serial number was. We knew exactly what DIMM slot it was in. Now, the whole of this operational was hosted in SuperNAP in Las Vegas. I would encourage you guys to go and Google SuperNAP when you come out of here. It is a really awesome data center. It's a really scary data center because as you walk into the data center, there's a rack of M16s in the reception desk behind the guy taking your details. That's because SuperNAP hosts a lot of 3-letter US agencies. So it's a very, very secure appliance. They want you in and out of there as quickly as possible. From the time I arrived on site, walked through the front door, fixed the DIMM, and came back out was an entire time in and out of 12 minutes because I knew exactly which DIMM I was replacing. It was back in service, and our partners who are going to talk later on today, Paul Todd's here from HA, RSF worked flawlessly in that case. VMware saw no loss of service. I'm very proud of that fact. I also have my fingers crossed because actually the timing that we had the DIMM failure was really good because they were halfway through changing their seats over. So they only had about 256 active seats at the point we failed over. And I think that was contributing to the fact that no one saw a latency drop at all. In fact, the only reason that the NOC knew about it was the fact that one of my colleagues, when he saw the thing fail over, was up out of his chair faster than Usain Bolt, and in the NOC telling them that they might have a problem before their messaging system had managed to get it through the SMTP servers and back to them to tell them that they'd had a problem. The fact that we'd purposely put a 2-minute delay in any warning to the VMware guy so we knew about it first was beside the point, right? So head over provisioning isn't always a bad thing, right? So we had 4 heads. It was no problem at all. In fact, one of my colleagues at the show made a very brave statement at the end of the show. So the VMware IT, Dan Anderson from the VMware IE team came up to us at the end of the show. We were talking about how the show went. He said, so what would you guys do next year? And my colleague's brave response was, oh, next year we'll try running the show on 2 heads. To which the other 2 of us looked at him and went, are you mad? So we'll see what happens this year if we're invited back. Most important bit about this session is what did we learn from the labs? So we learned taking a chance is good, right? And we learned that we can provide high performance storage that can go toe to toe with EMC and NetApp. I'll give you an example of the price of our hardware solution. This whole entire stack, from a storage point of view, was delivered at $325,000. The other 2 vendors, one of them was $1.5 million plus, and the other vendor was $2 million plus at list price. So this platform ran half the workloads, stood toe to toe with those vendors, and EMC's delivery number of IOPS from their platform was a very, very similar number to ours. Things we learned during the labs. Well, the first one was analytics. So we're halfway through the labs. We're setting up for the labs on the first day. And the IE team came across to us and we said, oh, we're talking about our analytics. We got this really cool, one of my colleagues, Craig Morgan, I don't know whether you've met him, was talking about what the labs would look like, okay, and what analytics we could provide for the labs. Because when we'd arrived there 2 days before, there's this great big Jumbotron screen in the labs where you can see what's going on. They talk about workloads and how some of the hypervisors are doing and how some of the storage is doing. It's displayed on this big screen. And in the NOC is a 50-inch plasma TV that all the guys from VMware are watching to see what's going on. So basically we said to them, how would you like to be able to take a single view look at our storage and be able to see what the platform's doing? And they went, well, that's a great idea. That would be really great. And we were all discussing while we were all drinking coffee over, you guys have all, how many people in the room manage storage? Okay. You've got those graphs where you see what the latency was or what the IOPS was, okay? And you have to go back and look through the graph and try and figure out what's going on your storage platform, right? It takes all of us a little while. We wanted a single point in time, you know, how can you look at 5 graphs at once, compare them all, and instantly tell you what your storage is what's going on in your storage? So basically, we came up with this idea that how could we put as much information on one screen as densely as possible for you that made sense to a human brain. And when I say human brain, I have another couple of my colleagues that are experts in reading dtrace. Who's seen The Matrix, right? Sit there and watch all these numbers come pouring down the screen, right? And one of my colleagues turns around and goes, did you see that latency blip? And I'm going, what latency blip? It's like, scroll back. Okay? It's incredibly impossible. And the power of dtrace that we have within Next Center Store is really, really important to us for that. Okay, so we have 75,000 kernel calls that we can trace in real time. And if you start doing more than one of those screens at once, I mean, you really do have to be a NASA genius to kind of monitor that stuff. So how could we make that sort of stuff really simple for system operators, like some of you in the room, to see at one glance? And what sort of information do we need on there? NFS IOPS, you know, not raw disk IOPS, NFS IOPS or CIFS IOPS, latency for particular data stores, latency for particular VMs. And we had all that input while we're having a coffee. And Dan Anderson, who, as I said, was the head of the IE team at the time, comes walking past about half an hour later. And Craig's going, I've done a quick sketch for you, Dan. Looked a bit like this. Yep. Go to the next one for me, sorry. Looks like that, right? He said, what do you think that would look like? Dan goes, that looks awesome. When could you do it by? And I'm sitting there waiting for Craig to go, oh, we'll do it for the Copenhagen show in 2 months, right? Or we'll do it in 3 months' time, or we'll let you play with the demo. Craig goes, how about if we could have it running by tomorrow? To which was another one of those times where I looked at Craig and went, are you mad, right? Okay, Pierre, who's not in the room, he's at the show, Pierre Dampman, who works for us, one of our really cool guys in the coding team, decided that he was up for a challenge and he stayed up for 24 hours. We wrote him some dtrace. To be honest, we were up for nearly 24 hours as well. And the next, we promised to deliver it for the start of the show, right? We were about 3 hours late. But I still think it was an awesome effort because the next day, at about 11 in the morning, we delivered that, hand-coded in OpenGL. You might say, what the hell is that? How the hell do I read it? Does it make sense? So if I explain a bit about it, you might kind of see how we think this is a really cool piece of implementation that we're putting into Next Center Store for you. Okay? So if you look, there's an orange block and a green block. What do the green blocks represent? Those green blocks represent the top 11 VMs or data stores that VMware were running. In there is normally a source address. We have to take the source address out because this is a screenshot from VMware's actual cloud. So I can't leave all the IPs in there because VMware will not thank me. The last block that says others, down on the sort of 5 o'clock position, is a combined number from all the other data stores, because obviously we had a lot more hosts involved here. The next center store is the orange block. Round the outside you see green and blue bars. They're read and write bandwidth. Okay, so you can instantly see from looking at those bars whether one box is doing more reads than it's doing writes. The most important one from this, what we call the aura chart, is those segment or chords that we see, those bands that you see running backwards and forwards between the two. And what they show you is, first of all, the color of the chord shows you the average latency for the data store. The lighter the color, the better. If it goes red, it's a very bad thing and we're running to the knock again. Okay, so you can see from the color what the latency looks like, and the direction of the flow of the data is whether it's a read or a write. The width of the core is the number of NFS IOPS, in this particular case, that data store is doing. So instantly, you're looking at one chart that gives you megabytes per second bandwidth, IOPS, and latency, all from one visualization. So like I said, if that turns completely red, that means that your data store is in real trouble. And one of the really cool things that you saw was at one point during this, we saw all the blue lines line up and form a complete curve around that, and that meant everybody was doing a read from the storage at exactly the same time, right? 100% read workload from all the clients, right? So that type of visualization is really important to you, because it means you can look at one place what the state of the data store was. We have some traditional bar graphs on the left-hand side as you guys look at it. NFS IOPS over the last 5 minutes, back-end IOPS, disk IOPS over the last 5 minutes, so you can see how those two track together. And most importantly for the VMware guys, that they were struggling to get from any of the other vendors involved, was this chart down the left-hand side. This is the top 20 file names, or VMDKs, being accessed in terms of NFS ops. So that gave you the drill down to an individual VM level of which VMs were causing you a problem, or potentially causing you a problem. And in fact, during the show, this tool was used. VMware were suffering from a latency problem on day 2. And there were about 40 really smart guys from us, EMC, NetApp, VMware, the switch vendor, all sat in, or multiple switch vendors, all sat in the NOC trying to figure out where this latency was coming from. And what we did was we provided them with a drill down list in real time, monitored as to what was going on. And we found that a couple of VMDKs were coming up time after time after time after time. And what it turned out is one of the labs had an iSCSI emulation inside the lab, and the traffic wasn't set on the virtual switch for just that lab. So actually the 3260 traffic from that lab was spilling out over the entire VMWorld network. And it was our ability to be able to trace down to that VMDK so that people could go away and look at what that lab was doing, that enabled them to find and fix the problem. So we changed the visualization for the show based on some input that we had after that. VMware asked for some different information. Secondly, someone thought it was a good idea to change the colors. I do have to apologize, everybody in Next Center is colorblind. You know, green and orange logo, and then we come up with this, right? Okay, so I personally don't like the second colors. As you can see, the latency goes from light to dark again in the bottom right-hand corner. But the really cool thing that we added that they wanted was block alignment on a per operation basis. So we could tell VMware how many of their VMDKs were aligned just by monitoring it with dtrace. So we can tell them in real time for every IOP whether the alignment is 100%, 50%, completely out in its entirety. So they asked us to add that. We added a couple of other things to that data store that I told you about. The first version you saw just had NFS IOPS, right? The second part of the chart had bandwidth to that particular VMDK, IOPS to that particular VMDK, NFS IO size to that particular VMDK, and most importantly, latency in microseconds for that particular one operation. Take note of that. I didn't say latency for the data store. I didn't say latency for the VMDK as a whole. That's a per NFS IOPS latency report from the point it comes into the ring buffer on our network card to going through our entire stack, being served back out and going out on the ring buffer on our network card, again out onto the network. The VMware guys really liked that. The last column is a bandwidth delay product based of that, which is a calculation based on that the VMware guys like to have pushed up into VCOps. There's a video clip available. The slide notes I think are going to be posted for you, so I would encourage you to go and have a look at that in flight, where we capture, I think it's about a 5-minute version of the real VMWorld load running, so you can see what the load was and how that graph actually dynamically moves on you. The moving version of the graph's obviously a lot more interesting. But what we're going to do with the Aura chart, so the Aura chart's now coming into Next Center Store, this type of drill down analytics. To be honest, our analytics haven't been too good to date, but this type of analytics are coming into the new versions of our product. We'll be able to provide you drill down information. So basically, you'll be able to pick one of the hosts in the outer ring, click on that host, be able to drill down into some more analytics based on that host, where that's hosted, some more information in that. And we're also working very closely with VMware. So for you guys that have mentioned the VSA for View announcement, we're working with VMware's CTO office. We're going to be pushing this information up into VCOps. So for those of you who run VCOps environments, you'll be able to monitor the state of your VMware stuff and get all this cool graphed information from within the VMware interface. So what was the thing that we learned from doing VMware? One of the slides we skipped past, if we can just go back to that one, because I want to show. We gathered 40 gigabytes of log information during the show. That's a huge amount of log information. Okay. We had one-to-one interaction with 30 VMware Plus IE specialists who had all different levels of expertise. So we got to interact during this project with some of the really cool guys and get a vision of what VMware want to see out of storage going forward. It was an extreme lag experience. You couldn't recreate this workload in a lab, right? You would have to spend months, if not years, trying to bring this up in a lab and make it simulate what a real workload looks like. Okay, so if you could bring up an infrastructure, that number of VM cores in your lab, which would be an expensive thing to do, and I'm sure Bill Fuller, our VP of Engineering, doesn't want me to propose a lab back at Santa Clara that's quite this large. Okay, so we got that type of information that we wouldn't have got before. And as I said, test routines, you can do simulation workload stuff, you can fire up test scripts. It's never going to look what a real workload looks like. And that's what this brought for us. It gave us a chance during the setup file to compare, setup stage to compare block and file on our appliance, both from a performance point of view and how it worked with VMware Stack. VMware chose to do file for the entire VMworld show based on that information that us and the other vendors did when we did the pre-phase testing for them. The reason they chose file is the fact that file gave us that level of insight as to what was going on a per VM basis that you just can't get out of block, right? So if I've got 100 VMs in a block, I can tell you what the block storage is doing as a whole. I can't drill down and tell you what each of the VMs within that block are doing from the storage side of the house. I can see it from the hypervisor side of the house, but I can't see what's going on the network layer or what's going on the particular storage side of the storage side of the house. We also saw that at extreme scale, metadata can become an issue, and metadata performance is a consideration that you might want to take into account. And we're doing some work in the background that came out of these labs for how we can improve the metadata performance of an X-Center Store appliance. And it also taught us that what features can we jointly go and get better business relationships with the other vendors in the stack. So we're talking about having dtrace capability on some of the other vendors' network stacks now. So we'll be able to do end-to-end dtrace between the storage appliance and the end of the network stack. Combine that with what VMware and Citrix and Zen are putting into management within or analytics within the hypervisor stack. Hopefully, in maybe a year's time, everybody in the room who deals with virtualized infrastructures will have an end-to-end view on a per user basis of what's going on within their VM stacks. So as I said, granular visibility is what we feel to be the key thing that we learned out of this. You as customers need granular visibility of their endpoint storage users. What do I mean by that? Let's say you're a hosting provider. You need to be able to see what your users using your platform on a per user basis are using your platform for. Okay. Once a problem customer has been identified, we need to provide you better tools to aid the diagnosis of the problem within the VM. Okay, like I said, things like average I/O size, latency per IOP, historic trending of that particular VM, i.e. collecting all that data into some sort of a database so you can trend that over time, not just the 30-second window or the 5-second window or the last 3 minutes. How's it been doing over the last week, month, year? Okay, look at block alignment issues. And the other really cool thing we've looked at this is ZFS has something called a TXG. It's commit interval, the fact that we take all those random writes and then we put them into a sequential stream and then we flush them to disk. Is it possible for us to maybe auto-tune that setting so it's not a set hard-coded setting so that the appliance learns even more over time and adjusts the window of the TXG as you push it harder or you work it less? Can we get more throughput because at the moment you need more throughput than you need IOPS? Or can we dial up the IOPS because your throughput numbers come down but now you're sending me a whole pile of small file I/O? So auto-tuning of the appliance is something else we're looking at. So with that, I think I'm about done. I think I've got about 5 minutes and I'll take any questions from anybody.
Which version do you expect that we can have that late Aura Fusion with granular visibility?
AuraGraph. So AuraGraph is deployed at several of our enterprise customers right now. It's in beta. 3 of our largest customers are using it. We haven't got a scheduled release date for that. If you want to drop me an email at the end, the minute we get close to a public alpha or a public beta, I'll get that out to people. Any other questions? Cool, we get to go to a break for a couple of minutes early. Thank you very much.